And welcome everybody to our bonus feature segment. The first thing we're looking at is the total electron content forecast, showing us the most likely areas for GPS errors. We do see some over North America here, but they're primarily, well, there's a little bit of chaos happening there at nighttime. In Antarctica over the North Atlantic Ocean. We'll let it play through one more time. The total electron content forecast shows you the free electrons in the thermosphere, ionosphere, and plasmasphere and their electrodynamics. Hence CTIPE, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Continuing on, here's a diagram of what we were just looking at. Your GPS satellite's located about 12,500 miles of altitude, way up there in its geosynchronous orbit, and the more electrons it has to communicate through, the more likely you are to have huge GPS errors. We see some minor charging hazards here over the northern Indian Ocean, the country of India moving into the Middle East. Some minor surface charging hazards there caused by some relativistic electrons. Here's the 1-year chart of the greater than 2 mega electron volt electron flux as reported by Solon.info. Here's the 3-day chart. We're seeing a little lower levels here than we were perhaps expecting. Here's the electron forecast model. I was incorrect with yesterday's forecast. We can expect an uptick coming here soon, but there is also another coronal hole wind stream, so we may be off by a lot. And when I say we, I don't mean NOAA. I'm talking about the smAsh team. smAsh staff and I. Anyway, next year, ionosphere. The F layer is located at about 300 kilometers of altitude. Here's your ionogram. Once again, thanks to the smAsh team, we've put these videos behind a paywall because of YouTube algorithms and because of censorship and all kinds of other stuff like that. So here's your ionogram for the past day. Here's the anomalygram showing anomaly in megahertz from the 30-day median. Remember, folks, March is the second most geomagnetically effective month, following only September. So September is the most geomagnetically active month. March is the second, and it all has to do with the equinoxes and magnetic field force lines and the perpendicular nature of them with respect to incoming solar protons and so on. So here is the ionogram from 11 o'clock Universal Time. Here's the anomalygram from 11 o'clock Universal Time. Tell your friends and foes about us, folks. If you weren't aware, these videos have been moved into an unlisted status. So you've got to log into smashamash.com/smashTeam. We're also on Twitter. Become Twitter account holders if you're not already. You'll see content nobody else gets to see. Also, feel free to visit our homepage at smashamash.com. Welcome to the Neo Renaissance. Thanks again to the smAsh team, the true source of funding for the content. We replaced Patreon with a superior service at smashamash.com/smashTeam. Also, check out the merch. You can find links below the video to that. Here come additional bonus features. So here's the ground-based solar observatory imagery from El Teide, Spain, and we've got massive plasma filaments. See these absorption features here and all these dark features up here. Those are all plasma filaments, folks, and they could be headed our way at any moment. Remember, folks, you don't even need a solar flare to see a coronal mass ejection. It's something to keep an eye on, and when I say ion, well, pardon the pun. Next, your latest intensitygram and colorized magnetogram. Sunspot 29, 54, and 55 are setting. 29, 56 looks like it's decayed to plage. That's another active region there. Not a sunspot over there in the northeast. The most interesting sunspot at the moment is 2959. That's this one that just rose in the southeast. And 2957 has quite a few umbrae as well. I'm not sure if this one is going to be considered the same sunspot or named something different. It's all good. There are the fields, and that's capable of producing flares and coronal mass ejections. That is the most likely suspect to produce major coronal mass ejections, in my opinion. Here's the rest of the colorized magnetogram. That's a plage at the moment, not a sunspot. There's that active region, and there's the area around 2954 and 2955. We'll close out with some additional solar imagery here We've got some spectacular bonus features, and thanks to the smAsh team for funding the operations. These bonus features are dedicated to our longtime gold and silver smAsh team members. So here's this great composite imagery here in 171 and 193 angstroms. It's showing magnetic loops and filaments. We've even got a close-up of that filament toward the bottom of your screen there. This one down here. In some different wavelengths. First, a full disk view in 304 plus 193 angstroms. Spectacular imagery over the past 24 hours. A lot of different wavelengths showing a lot of different interesting features. We've slowed down the imagery a little bit here to give you a little additional temporal detail. So thanks again for tuning in, folks. Thanks to the smAsh team. Don't forget to tell your friends and foes about the content. It is now paid only. And thanks to everybody who has been paying. And may that solar wind be at your back.